Find the domain of the following functions. Okay, so we're looking at a domain, the domain of a function, and let's go. So A says f of x is equal to the root of 6 minus 4x. So what do we mean by domain? Well, domain is a set of numbers, all right, that defines a certain or a particular function. All right, these numbers, they make a function definable. Alright, then the output is what we call the range. So we're looking for a number or the set of numbers which is going to make this function defined. All right, so when you are given a function of a root like in this nature, what you need to know is that we cannot have a negative under an even square root. Yes, this one is an even square root because there's a 2 there. Okay, so this one is an even square root. You can't have a negative under an even square root. So to avoid the negative under that root, what we do is that we can only have a 0 or a number above 0, meaning 0 or positive. So what do? You get what is inside here, you set it to equal to or greater than 0. So you say 6 minus 4x should be greater than or equal to 0. Nothing less than 0. Greater than or equal to. All right, and of course when you solve, you get that and you end up getting this. So what is this telling you? Meaning the domain, we are looking for all values of x, all right, that are less than or equal to 3/2. Any number which is less than or equal to 3/2, when you plug it there, the square root will be positive and not negative. Okay, the other way you can write this, all right, you can use brackets or build a notation. You can say, okay, we are looking for the number that are less than, all right, meaning all the way from negative infinity to 3/2, but this will not be included, but this will be included like that. Same concept applies here. We, of course, here we are not going to get that. We are only going to consider the denominator, all right? And our denominator is x squared minus 4, all right? So you equate that guy, you say equal to 0. Here you cannot say less than or what? We just say equal to 0, okay? The reason is simple, is that we cannot evaluate this odd function, all right? We cannot evaluate it. All right, so what we need to do is that we just have to restrict the numerator, and then we work out the denominator. That's all. So if factorize using the difference of two squares, we get x minus 2, and we get x plus 2, and that is equal to 0. So here we are saying that x is 2 or x is negative 2. So meaning that your domain, okay, it will be, okay, or what can I say? The numbers, because there's this, all right, meaning the whole real number line, you know, the real number line, right? That line from positive infinity, so negative infinity to positive infinity, x can only be 2 or negative 2. The reason is this: if you put 2 here, okay, here you get 0, and 0 can't go into anything. So what do these mean? This means that x, if I even write the domain, this means that x cannot be 2 or negative 2. We don't need x as 2 or x as negative 2, because if we put here, we are going to get over 0 there, and we can't divide the 0 into a real number, so that becomes something else. So we are trying to avoid 2 and negative 2, so we only focus on the numbers outside that. So what there are two ways you can report this. the first thing that in your real number line, we can subtract -2 and 2, okay? Or, I repeat, or we can get numbers that are not 2. Let's say a number after 2 or a number before 2, okay? So, for example, that x that we're looking for can be less than 2, sorry, or 2 can be less than that number. That is more sensible. Or you can say the number we can look for, it's this or that. But one thing that you need to realize here is that here it's like the number is between. So we are only looking for numbers that are down below 2, or those that are above 2, okay? But if you say below 2, we remove this, okay? So what you can report again is this: the domain is x such that x is a real number and x is not equal to, x is not equal to 2 or -2. You can also report it in that manner, like that.